Ever felt like you're drowning in the vast sea of machine learning concepts right before an interview? You're not alone. Navigating from bias variance trade-offs to the intricacies of ensemble methods can be overwhelming. In this video, we will cover Machine Learning Interview Preparation Questions and Answers Guide. Master your next technical interview with this comprehensive guide to 30 machine learning interview questions and answers. Today, we're diving deep into 30 essential machine learning interview questions, complete with detailed explanations. Whether you're a seasoned pro or just starting out, this guide will help you solidify your understanding and boost your confidence for your next big opportunity. Before we get started, hit that subscribe button and ring the notification bell so you never miss out on our expert interview preparation content. Ready to ace your ML interview? Let's dive in. What is the primary difference between supervised and unsupervised machine learning? Option A. Supervised learning uses in-labeled data, while unsupervised uses labeled data. Option B. Supervised learning requires a human in the loop, while unsupervised does not. Option C. Supervised learning uses labeled data to predict outcomes, while unsupervised finds patterns in labeled data. Option D. Supervised learning is only for classification, while unsupervised is for regression. The correct answer is C. Supervised learning involves training a model on a dataset where the target variable is already known. Labeled data. The goal is for the model to learn the mapping from inputs to the known outputs so it can predict outcomes for new, unseen data. In contrast, unsupervised learning deals with data that has no predefined labels. The algorithm attempts to discover inherent structures or patterns within the data on its own, such as grouping similar data points, clustering, or reducing the number of variables. Dimensionality reduction. Which of the following metrics is most suitable for evaluating a classification model on an imbalanced dataset? Option A. Accuracy. Option B. F1 score. Option C. Mean squared error. Option D. R squared. The correct answer is B. Accuracy can be highly misleading when dealing with imbalanced datasets. For example, if 99% of your data belongs to one class, a model that always predicts that class will achieve 99% accuracy but fail to identify the minority class entirely. The F1 score, which is the harmonic mean of precision and recall, provides a more balanced view of the model's performance, especially when you need to account for both false positives and false negatives. Mean squared error and R squared are metrics primarily used for regression tasks, not classification. How does the k-nearest neighbors, KNN, algorithm make a prediction for a new data point? Option A. By finding the hyperplane that best separates different classes. Option B. By calculating the probability of the point belonging to each class based on Bayes' theorem. Option C. By identifying the k most similar data points in the training set and taking a majority vote or average. Option D. By iteratively adjusting weights to minimize a loss function. The correct answer is C. KNN is a simple, instance-based learning algorithm. When a new data point needs to be classified, or its value predicted, the algorithm calculates the distance, e.g., Euclidean distance, between that point and all other points in the training dataset. It then identifies the k points that are closest, most similar, to the new point. For classification, the new point is assigned the class that is most common among its k-nearest neighbors. For regression, The predicted value is typically the average of the values of its k nearest neighbors. What is the main advantage of L1 regularization, lasso, over L2 regularization, ridge? Option A. L1 regularization always results in higher model accuracy. Option B. L1 regularization can shrink some feature coefficients exactly to zero, performing automatic feature selection. Option C. L1 regularization is computationally less expensive than L2. Option D. L1 regularization is better suited for handling outliers in the data. The correct answer is B. Both L1 and L2 regularization are techniques used to prevent overfitting by adding a penalty term to the loss function based on the magnitude of the model's coefficients. L2 ridge adds a penalty proportional to the square of the coefficients, which tends to shrink all coefficients but rarely makes them zero. L1 lasso, however, adds a penalty proportional to the absolute value of the coefficients. This property often leads to some coefficients being reduced exactly to zero, effectively removing those features from the model. This makes lasso particularly useful for feature selection in datasets with many irrelevant or redundant features. What is the key difference between bagging and boosting ensemble techniques? Option A. Bagging builds models sequentially, while boosting builds them in parallel. Option B. Bagging aims to reduce bias, while boosting aims to reduce variance. Option C. Bagging builds independent models in parallel and averages their results, while boosting builds models sequentially, each one trying to correct the errors of its predecessor. Option D. Bagging can only be used with decision trees, while boosting can be used with any algorithm. The correct answer is C. Bagging, bootstrap aggregating, involves training multiple versions of a model, often decision trees, on different random subsets of the training data created through bootstrapping. These models are trained independently in parallel, and their predictions are combined, e.g., by averaging or voting, to reduce the overall variance and prevent overfitting. Boosting, on the other hand, is a sequential process where each new model is trained to focus on the examples that the previous models found difficult or misclassified. The final prediction is a weighted combination of all the models. Boosting primarily aims to reduce bias and create a strong learner from a collection of weak learners. In principal component analysis, PCA, what do the principal components represent? Option A. The original features that have the highest correlation with the target variable. Option B. New, uncorrelated variables that are linear combinations of the original features and capture the maximum variance in the data. Option C. The clusters identified within the dataset. Option D. The most important data points, outliers, in the dataset. The correct answer is B. PCA is a dimensionality reduction technique that transforms a large set of variables into a smaller one that still contains most of the information in the original set. It does this by identifying new, orthogonal, uncorrelated axes called principal components. The first principal component is the direction in the feature space along which the data varies the most. The second principal component is the direction of next highest variance, subject to being perpendicular to the first, and so on. By keeping only the first few principal components, you can reduce the dimensionality of your data while retaining most of its significant information. What is the role of the learning rate in gradient descent? Option A. It determines the total number of iterations the algorithm will perform. Option B. It specifies the size of the steps taken towards the minimum of the loss function. Option C. It controls the complexity of the model being trained. Option D. It defines the threshold for stopping the training process when the model has converged. The correct answer is B. Gradient descent is an iterative optimization algorithm used to find the minimum of a function, typically a loss function. The learning rate is a hyperparameter that controls how much the model's parameters are adjusted in each step based on the gradient. If the learning rate is too small, the algorithm will take a very long time to converge. If it's too large, it might overshoot the minimum and fail to converge or even diverge. Finding the right learning rate is crucial for efficient and effective model training. Why are nonlinear activation functions, like ReLU or sigmoid, essential in neural networks? Option A. To ensure that the outputs of the network are always between 0 and 1. Option B. To speed up the training process by simplifying the calculations. Option C. To allow the network to learn and represent complex, nonlinear relationships in the data. Option D. To prevent the weights from becoming too large during backpropagation. The correct answer is C. A neural network without any nonlinear activation functions, regardless of how many layers it has, would simply behave like a single-layer linear model. This is because a linear combination of linear functions is itself a linear function. Nonlinear activation functions introduce the nonlinearity necessary for the network to approximate any continuous function, allowing it to learn much more complex patterns than a simple linear regression or logistic regression model ever could. A model that performs exceptionally well on training data but poorly on new, unseen test data is likely experiencing which of the following? Option A. High bias, underfitting. Option B. High variance, overfitting. Option C. Optimal performance. Option D. Data leakage. The correct answer is B. Overfitting occurs when a model learns the training data too well, including its noise and outliers, to the point that its ability to generalize to new, unseen data is compromised. This results in low error on the training set but high error on the test set, indicating high variance. Underfitting, high bias, on the other hand, happens when the model is too simple to capture the underlying structure of the data, resulting in poor performance on both the training and test sets. What is the purpose of one-hot encoding in data preprocessing? Option A. To convert continuous numerical features into discrete bins. Option B. To handle missing values by replacing them with a unique category. Option C. To convert categorical variables into a numerical format that machine learning algorithms can understand, without implying any ordinal relationship. Option D. To normalize the range of numerical features so they all have a mean of 0 and a standard deviation of 1. The correct answer is C. Many machine learning algorithms require their input data to be numerical. However, many real-world datasets contain categorical variables, e.g., color, red, green, blue. Simply assigning each category a number, e.g., 1, 2, 3, can be problematic because it might imply a non-existent order or ranking. One-hot encoding creates a new binary, 0 or 1, column for each unique category in the original variable. For a given data point, only one of these new columns will have a 1, representing its category, while all others will have zeros. This allows the model to treat each category as a distinct, independent feature. In the k-means clustering algorithm, how is the elbow method typically used? Option A. To identify and remove outliers from the dataset before clustering. Option B. To determine the optimal number of clusters. K. By plotting the sum of squared distances against K. Option C. To select the initial positions of the cluster centroids. Option D. To measure the distance between different clusters. The correct answer is B. K-means requires the user to specify the number of clusters K in advance. The elbow method is a common heuristic used to find the best value for K. You run the algorithm for a range of K values and for each K, calculate the within cluster sum of squares, WCSS, which measures how compact the clusters are. When you plot WCSS against K, the value typically decreases as K increases. The elbow of the curve, the point where the rate of decrease significantly slows down, is often chosen as the optimal K because adding more clusters beyond this point doesn't provide a significant improvement in capturing the data's structure. Which of the following is an advantage of random forest over a single decision tree? Option A. Random forest is much easier to visualize and interpret. Option B. Random forest is less prone to overfitting because it averages the results of many trees. Option C. Random forest requires much less computational power and time to train. Option D. Random forest doesn't require any hyperparameter tuning. The correct answer is B. A single decision tree can easily become very complex and overfit its training data, especially if it's allowed to grow deep. Random forest addresses this by creating an ensemble of many decision trees, each trained on a different bootstrap sample of the data and using a random subset of features at each split, by averaging the predictions for regression, or taking a majority vote for classification across all the trees. Random forest significantly reduces the overall variance and is much more robust to noise and overfitting than any single tree. What information does a confusion matrix provide for a binary classification problem? Option A. The distribution of values for each feature in the dataset. Option B. The importance of each feature in making predictions. Option C. The counts of true positives, true negatives, false positives, and false negatives. Option D. The optimal value for the model's hyperparameters. The correct answer is C. A confusion matrix is a table used to describe the performance of a classification model on a set of data for which the true values are known. For a binary classifier, it has 4 entries: true positives, TP, correctly predicted positive cases; true negatives, TN, correctly predicted negative cases; false positives, FP, negative cases incorrectly predicted as positive; and false negatives, FN, positive cases incorrectly predicted as negative. This matrix provides the fundamental data needed to calculate many other evaluation metrics like precision, recall, and accuracy. What is dropout, and why is it used during the training of neural networks? Option A. It's a technique for removing layers from a network that aren't contributing to the output. Option B. It's a regularization method where some neurons are randomly ignored during each training step to Prevent over-reliance on specific connections. Option C. It's a process for reducing the size of the input data to speed up training. Option D. It's an activation function that helps the network converge faster. The correct answer is B. Dropout is a powerful regularization technique specifically designed for deep neural networks. During each training iteration, a random subset of neurons, along with their connections, is temporarily removed from the network with a certain probability. This forces the remaining neurons to learn more robust features and prevents the network from becoming overly dependent on any specific set of neurons, effectively reducing overfitting and improving the model's ability to generalize to new data. Explain the bias-variance trade-off in machine learning. Option A. It's the process of choosing between a complex model with low bias and a simple model with low variance. Option B. It describes the challenge of simultaneously minimizing both the error due to overly simplistic assumptions, bias, and the error due to excessive sensitivity to training data noise, variance. Option C. It's a method for balancing the amount of training data and test data in a split. Option D. It's a technique for selecting the best features for a model. The correct answer is B. The bias-variance trade-off is a central concept in machine learning. Bias refers to the error introduced by approximating a real-world problem with a simplified model. High-bias models, like linear regression on nonlinear data, tend to underfit. Variance refers to the error introduced by the model's sensitivity to small fluctuations in the training set. High-variance models, like very deep decision trees, tend to overfit. As you increase model complexity, bias generally decreases but variance increases. The goal of any machine learning practitioner is to find the sweet spot where both bias and variance are minimized, leading to the lowest overall error on new data. What is the primary purpose of k-fold cross-validation? Option A. To increase the amount of data available for training a model. Option B. To ensure that the model is trained on the most important features. Option C. To provide a more reliable and robust estimate of a model's performance on unseen data by using multiple different train test splits. Option D. To automatically tune the hyperparameters of a model. The correct answer is C. K-fold cross-validation is a technique used to evaluate how well a machine learning model will generalize to an independent dataset. The original dataset is randomly partitioned into k equal-sized subsamples, folds. The model is then trained k times, each time using k1 folds for training and the remaining fold for testing. The final performance estimate is the average of the results from all k iterations. This approach ensures that every data point is used for both training and testing, providing a more comprehensive and less biased evaluation than a single train test split. How does a support vector machine, SVM, determine the optimal decision boundary? Option A. By finding the line that passes through the mean of each class. Option B. By maximizing the margin, the distance between the decision boundary and the nearest data points from each class. Option C. By calculating the probability of a point belonging to each class. Option D. By minimizing the total number of misclassified points in the training set. The correct answer is B. SVM is a powerful classification algorithm that aims to find a hyperplane in a high-dimensional Space that clearly separates data points of different classes. The optimal hyperplane is the one that has the maximum margin, meaning it's as far as possible from the nearest data points of any class. These nearest points are called support vectors. A larger margin provides better generalization because it's less likely that new, slightly different data points will fall on the wrong side of the boundary. What is the difference between batch gradient descent and stochastic gradient descent, SGD? Option A. Batch gradient descent updates weights after seeing each individual data point, while SGD updates after seeing the entire dataset. Option B. Batch gradient descent is only for linear models, while SGD is for nonlinear ones. Option C. Batch gradient descent updates weights using the entire training set at once, while SGD updates them using only one randomly selected data point, or a small, mini batch, at a time. Option D. SGD is guaranteed to find the global minimum, whereas batch gradient descent may get stuck in local minima. The correct answer is C. Batch gradient descent calculates the gradient of the loss function with respect to the entire training dataset before performing a single update to the model's parameters. This can be very slow and memory intensive for large datasets. SGD, on the other hand, updates the parameters after seeing only one data point, or a small subset called a mini batch. This makes it much faster and allows for online learning, while the path taken by SGD is noisier and more erratic. This stochasticity can sometimes help it jump out of shallow local minima and find better solutions. What is the function of pooling layers? Like max pooling in a convolutional neural network. CNN. Option A. To apply nonlinear transformations to the features. Option B. To reduce the spatial dimensions of the feature maps, decreasing the number of parameters and computational load. Option C. To increase the number of features learned by the network. Option D. To normalize the outputs of the previous layer. The correct answer is B. Pooling layers are commonly used in CNNs to downsample the feature maps generated by the convolutional layers. Max pooling, for example, takes the maximum value from a small window, e.g., 2x2, of the feature map and passes it to the next layer. This process reduces the spatial size of the representation, which not only decreases the amount of computation required in subsequent layers but also helps the network become more invariant to small shifts and distortions in the input image. What is reinforcement learning primarily concerned with? Option A. Predicting a continuous target variable from a set of features. Option B. Grouping similar data points together without any labels. Option C. Training an agent to take actions in an environment to maximize a cumulative reward. Option D. Reducing the dimensionality of a dataset while preserving its information. The correct answer is C. Reinforcement learning, RL, is a type of machine learning where an agent learns to make decisions by interacting with an environment. The agent receives feedback in the form of rewards or penalties based on its actions. Its goal is to learn a policy, a mapping from states of the environment to actions, that maximizes the total reward it receives over time. RL is widely used in applications like robotics, game playing, e.g., AlphaGo, and autonomous driving. Which of the following algorithms is based on Bayes' theorem and assumes that features are independent of each other? Option A. Logistic regression. Option B. Support vector machine. Option C. Naive Bayes. Option D. Decision trees. The correct answer is C. Naive Bayes is a probabilistic classifier based on Bayes' theorem. It's called naive because it makes the strong, and often unrealistic, assumption that all features in the dataset are independent of each other given the class label. Despite this simplification, naive Bayes often performs surprisingly well in practice, especially for text classification tasks like spam detection and sentiment analysis, because it's fast, easy to implement, and handles high-dimensional data well. What does the AUC-ROC score represent? Option A. The overall accuracy of a classification model. Option B. The model's ability to distinguish between different classes across all possible classification thresholds. Option C. The correlation between the model's predictions and the actual values. Option D. The percentage of variance in the target variable explained by the model. The correct answer is B. The ROC, receiver operating characteristic, curve plots the true positive rate, recall, against the false positive rate as you vary the classification threshold. The AUC, area under the curve, measures the entire two-dimensional area underneath the ROC curve. An AUC score ranges from 0 to 1, where 1 represents a perfect classifier and 0.5 represents a model that makes random guesses. The AUC-ROC is a valuable metric because it provides a comprehensive view of a model's performance that isn't dependent on a single arbitrary threshold. How does TSNE, T-distributed stochastic neighbor embedding, differ from PCA in terms of its goals? Option A. TSNE is faster than PCA for large datasets. Option B. TSNE focuses on preserving the global structure of the data, while PCA focuses on local structure. Option C. TSNE is a nonlinear technique designed for data visualization, focusing on keeping similar points close together in a low-dimensional space, while PCA is a linear technique that maximizes global variance. Option D. TSNE can only be used for classification, while PCA is for regression. The correct answer is C. While both are dimensionality reduction techniques, they have different strengths. PCA is a linear method that seeks to find new axes that capture the most overall variance in the dataset, effectively preserving the global structure. TSNE is a powerful nonlinear technique primarily used for visualizing high-dimensional data in 2D or 3D. It works by converting similarities between data points into joint probabilities and then trying to find a low-dimensional representation that minimizes the difference between these probabilities. TSNE is particularly good at revealing clusters and local structures that linear methods like PCA might miss. What is feature scaling, and why is it often necessary? Option A. Increasing the number of features in a dataset. Option B. Standardizing or normalizing the range of independent variables so they contribute equally to the model, especially for distance-based algorithms. Option C. Removing irrelevant features from the data. Option D. Converting categorical variables into numerical ones. The correct answer is B. Many machine learning algorithms, like KNN, SVM, and gradient descent, are sensitive to the scale of the input features. If one feature has a much larger range of values than another, e.g., age versus annual income. The algorithm might give it disproportionate importance simply because of its numerical magnitude. Feature scaling techniques, such as min-max scaling, normalizing to a 0 to 1 range, or standardization, scaling to a mean of 0 and standard deviation of 1, ensure that all features are on a comparable scale, leading to better model performance and faster convergence. Which of the following is not a common technique for preventing overfitting? Option A. Adding more training data. Option B. Using regularization, L1 or L2. Option C. Increasing the complexity of the model, e.g., adding more layers to a neural network. Option D. Using cross-validation. The correct answer is C. Overfitting happens when a model is too complex and captures the noise in the training data. Increasing the complexity of the model further is more likely to worsen overfitting. To prevent it, you should either simplify the model, use regularization to penalize complexity, provide more training data so the model can learn the true underlying patterns better, or use techniques like cross-validation to get a more realistic assessment of its performance on new data. What is the primary objective of the logistic regression algorithm? Option A. To predict a continuous numerical value. Option B. To group data points into an unknown number of clusters. Option C. To predict the probability of a data point belonging to a particular class in a classification problem. Option D. To find the best fitting line through a set of data points. The correct answer is C. Despite its name, logistic regression is a classification algorithm, not a regression algorithm. It uses a logistic function, or sigmoid function, to model the probability that a given input belongs to a certain class, e.g., spam or not spam. The output is always a value between 0 and 1, which can be interpreted as a probability. A threshold, e.g., 0.5, is then applied to these probabilities to make final class predictions. In the context of gradient descent, what is a local minimum? Option A. The absolute lowest point of the entire loss function. Option B. A point where the loss function is lower than all its neighboring points, but not necessarily the lowest point in the entire function's domain. Option C. The starting point for the optimization process. Option D. The point where the model's accuracy is highest. The correct answer is B. Loss functions in machine learning, especially for complex models like deep neural networks, are often not simple convex shapes. They can have many valleys or points where the gradient is 0. A global minimum is the very lowest point of the entire function. A local minimum is a point that is the lowest in its immediate vicinity but might be higher than the global minimum or other local minima elsewhere. Gradient descent can sometimes get stuck in a local minimum, preventing it from finding the absolute best set of parameters. How does the DBSCAN clustering algorithm differ from k-means? Option A. DBSCAN requires the user to specify the number of clusters in advance, while k-means does not. Option B. DBSCAN is a density-based algorithm that can identify clusters of arbitrary shapes and also handle noise outliers, whereas k-means assumes clusters are spherical and sensitive to outliers. Option C. DBSCAN is much faster than k-means for very large datasets. Option D. DBSCAN can only be used for numerical data. while k-means can handle categorical data. The correct answer is B. K-means is a centroid-based algorithm that works well for spherical clusters but struggles with more complex shapes and is heavily influenced by outliers. It also requires you to know the number of clusters beforehand. DBSCAN. Density-based spatial clustering of applications with noise. Groups together points that are closely packed together. High density. And marks points in low-density regions as outliers. It can find clusters of any shape, doesn't require you to pre-specify the number of clusters, and is naturally robust to outliers. What is transfer learning in the context of deep learning? Option A. Moving a trained model from one computer to another. Option B. A technique where a model developed for one task is reused as the starting point for a model on a second, related task. Option C. Converting a neural network into a decision tree for better interpretability. Option D. Using multiple GPUs to train a single model. The correct answer is B. Transfer learning is a highly effective technique where you take a pre-trained model, one that has already been trained on a massive dataset for a similar task, like image recognition on ImageNet, and fine-tune it for your specific, smaller dataset and task. This is much more efficient than training a model from scratch, as the pre-trained model has already learned many useful features, like identifying edges and shapes, that can be easily adapted to your new problem. What does the term hyperparameter refer to in machine learning? Option A. The parameters that the model learns from the training data, e.g., weights and biases. Option B. The configuration settings for the learning process that are set by the user before training begins, e.g., learning rate, number of hidden layers. Option C. The most important features in the dataset. Option D. The results of the model's evaluation on the test set. The correct answer is B. Model parameters, like weights in a neural network, are learned automatically from the data during training. Hyperparameters, however, are settings that define how the training process itself should work. They are chosen by the data scientist and remain constant during training. Examples include the number of clusters in k-means, the learning rate in gradient descent, and the maximum depth of a decision tree. Finding the optimal values for these hyperparameters is often a critical step in building a high-performing model. That concludes our walkthrough of 30 essential machine learning interview questions. I hope this detailed breakdown has helped clear up some concepts and gave you a better understanding of what to expect in your next technical assessment. If you found this video helpful, please give it a thumbs up and share it with your fellow ML enthusiasts. Also, let us know in the comments which topic you'd like us to cover next. For those looking for a comprehensive practice experience, check out the full exam link in the description below.